Hello guys, this is Paul McWhorter from TopTechBoy.com, and we are here today with lesson number 25 in our improved Arduino tutorial series. And what we're going to do today is we are going to learn how photoresistors or photodetectors work, and then we're going to learn how to hook them up and use them in an Arduino project. So I need you to pour yourself a nice big mug of iced coffee. Don't put sugar in it, and especially don't put those little sweetener packets in it. It is delicious just the way it is. Also need you to get out your eLego Super Starter Kit. If you haven't picked one up yet, go down to the description, click on the link, hook a brother up, $35. It's got an Arduino and a boatload of components, which we are using in this video series. You know, and one of the nice things about getting this is we're working with the same hardware, so life is just a lot easier for you, and it's a lot easier for me if we are working with the same hardware. All right, this is what you are going to need on today's project. You are going to need your Arduino. You are going to need two 330 ohm resistors. Look at this special day. You're going to get to use a green LED. Normally we just use red and yellow. Green is reserved for special occasions. So today will be a special occasion, and we will be using a green LED. You also, in your eLego kit, need to get a 5K resistor. You can see that there are these resistors, and it is labeled 5K for 5,000 ohms. And I'll explain why we need to use that in a minute. Also, in today's project, I'm going to be using this Mastech Digital Voltmeter. Really you can do this project without the voltmeter because you can just look at the readings that I'm getting. But if you guys don't have one of these, look in the link below, get you one, because you really, if you're going to be doing projects, if you're going to be doing electronics, you need to at least have one of these DVMs. So if you don't have one, strongly suggest you go out and figure out a way to get one. All right. So what we are going to do today is we will be working with the photodetector. Okay, the photodetector. It's this little thing. Let me see if I can give you a better look. See if it will focus on it. Hopefully no, it just wants to focus on me. Okay, there. I think you can see it. This little guy has two leads. All right. What does a photodetector do? Well, its resistance changes when the light changes. So as the level of light changes, the resistance changes, and then we will set up a circuit which will allow us on the Arduino to measure that change in resistance and know that that's due to a change in light. But I am going to tell you how these things work, and I am getting a lot of hate from some of you guys on these lessons where I'm trying to explain how things work or trying to do some math. And I think what you want me to do is, a lot of you just want me to post my code, and then you copy my code and hit download and everything works. But you know, someone at the end of the day needs to understand how these things work. Okay, this is how a photodetector works. A photodetector is, so this is a photoresistor, we'll call it. Okay, as the light intensity goes up, the resistance of the material goes down. So if we measure resistance, as the light level increases, the resistance goes down. Why? It is a semiconductor device, and it is pretty close to being an intrinsic semiconductor device. Go back and look at what I think was lesson number 2, and we talked about how diodes worked by drawing band diagrams. Got a lot of hate on that one. You're going to get more band diagrams today. I'm sorry. If we look at energy across the semiconductor, so just imagine that this is some dimension x along the length of the photoresistor. We have what happens if you have atoms, those atoms have very discrete energy levels that the electrons can be in. But if you bring the atoms together to form a crystal, if you form a crystal, then the atoms start coming together and those discrete energy levels start interfering with each other, and then they will smear out and make bands of allowed energy levels. This is called the conduction band, and this is called the valence band. You can have electrons in here, you can have electrons in here, but you cannot have them in this gap. This gap is the forbidden region. If you have an intrinsic semiconductor, the valence band is full of electrons, and the conduction band is empty. Why is that? Well, because marbles roll downhill. If you put a marble in the bowl, it's going to want to go to the lowest energy level. If you put electrons in a semiconductor, they want to go to the lowest energy. And here there's going to be almost no conduction. Why is there no conduction down here with all these electrons? Imagine you have a jar, and imagine the jar is full of marbles, and you shake it. The marbles don't move because it's full. Now have an empty jar. Shake it. No conduction, no marbles move because there are no marbles. So when you look at this, in this state, this intrinsic semiconductor is going to have a resistance that is very high. Why is the resistance high? Because there's almost no ability to conduct. But what happens if we send in a photon or light? That photon will kick an electron into the conduction band, or multiple electrons, because you have multiple photons coming in, and then there are going to be multiple electrons that are kicked up to this higher conduction band, this higher energy conduction band. Well, when the electron is kicked up here as the photons come in, what happens? I have an electron in this empty jar. He's free to conduct electricity. What do I have? I have missing electrons in the jar that's full. Now the other ones can move around. So what happens? I generate electron hole pairs from the photons, and what happens to the resistance? The resistance goes down. And so what happens is the more photons that you bring in, the more electron hole pairs you generate, and thus the more conduction that you can have, the resistance goes down. Okay, that's how this thing works. Now let's look practically at how it works. If I can find it, did I lose it? No, here it is. Okay. So now let's see practically how it works. And also we start getting a little bit more practically into the project, because in order to hook this thing into a circuit and design a circuit around it, in order to design a circuit around it, we really need to kind of know what its resistance values are. And so I need to get a fresh piece of paper and put here. And now what I am going to do is I have this, I might need to get out of your way a little bit more. Okay. I have this voltmeter, and it is set to the ohms reading, and I'm going to read the resistance across this device here by hooking up my leads and putting it where you can see it this time. All right, so do you see how, and these photodetectors like this, these photoresistors, they don't have a polarity either way. Either way is okay. All right, and so let's look at this, and I'm trying to point it right at the light, so at maximum brightness, you know, as it's really right looking at the light, the reading of the resistance is let's call it 1.5 kiloohms. So it's 1.5 kiloohms, 1.5 kiloohms when the light is all the way bright. So that's 1.5, and I know it changes a little bit, okay, but that is roughly what it is in full brightness. Now we have to darken the room, and so I will turn my studio lights off. Okay, Now, what do we expect, right? All that light coming in was generating electron hole pairs. That means that it's very conductive. That means that the resistance is low. So what do we expect when we turn the lights off? We expect the resistance to come up. And even turning off the studio lights, we can see that the resistance increased a little bit. But now let's really go dark. And as we really go dark, you can't read it because this is in the dark. Maybe you almost can, but you can see that it went up to 16 kiloohms when the lights are down. So and I will not turn the studio lights on so that we can kind of flip the lights as we need them. So what happens when we turn the lights off? We're not generating electron hole pairs. We don't have conduction. So when the light goes off, the resistance goes up. It makes sense. It makes intuitive sense if we're thinking about those band diagrams. All right, now we need to start thinking about a circuit because we want the Arduino to be able to know, are the lights on or are the lights off? And so what you can think of, and guys, this is really important because a lot of the components that you are going to be dealing with, a lot of the components, the sensors, the way they work is that whatever you're interested in, the resistance changes as that parameter changes. And so you can think of them as a variable resistor. So as the light changes, the resistance value changes. There's also temperature sensors that work that way, that as the temperature changes, the resistance changes. There's all types of sensors whose output is a change in resistance. So how do we detect a change in resistance on the Arduino? Well, the first thing that you might think is just take a pin on the Arduino and hook the sensor across it, and then as the resistance changes, the current's going to change. True, but what's the problem? You can't measure current in the Arduino. You can only measure what? Voltage. So in order to use one of these things, what you need to do is you need to connect it to the 5-volt pin, but you've got to put it in series with, this is your sensor, this is our light sensor, you have to put it in series with another resistor, a fixed resistor. And let's say I picked the 5K resistor deliberately because if you remember, our values were between 1.5 and 16K. You want the fixed resistor that you choose to be roughly in the range of what the variable resistor or the sensor is going to be. And so this is going to be 5K. All right, so what is the current? The current is going to be equal to the voltage divided by the resistance. And what is the resistance? It's our sensor plus 5K. All right, so as the light goes up, the resistance of this resistor is going to go down. And as this goes down, the current is going to go up. As the light is turned off, this resistance becomes larger, and as the resistance becomes larger, the current goes down. All right, so then that is also, if we think of voltage, is going to be current 5 over RS plus 5K times what? Times this 5K resistor, right? So I can measure the voltage right there. So what that's saying is that this voltage is going to change as the resistance changes, and the resistance is going to change with the light. So what that means is if we put this 5K resistor in series with this sensor, this voltage at this point is going to change. So what does that mean from the Arduino? Well, we don't have to use a control pin. What we just have to do is hook it to the 5 volts. We have to come across the sensor. Then we need to go through the 5K resistor, and then we need to come out here and go to an analog pin. And then on this analog pin, we can write a voltage, and that voltage will be very strongly related to what the current is. All right, so this is what we are going to do, and I will kind of do this along with you. All right, so let's start by hooking up our circuit with the, let me zoom in a little bit, and let's hook up our circuit with the Arduino. All right, so I'm going to come in, and where do I really need to get started? I need to get started with the photo detector, which I apparently have lost, which I have, oh, here it is, okay. That, I almost panicked there because I could not find the photo detector. So if we looked at the circuit, the first thing we want to do is go across the photo detector. So I'm going to put the photo detector or photoresistor between column 10 and column 15. And remember, the direction doesn't matter. And then I am going to come in, and I've got to make sure I use the right resistor, the 5K resistor, and not the current limiting resistors for the LEDs. I believe these two are the same, and this is the 5K resistor. I really need to teach you how to read resistors from those little rings one of these days. I'm going to go, the one leg of the resistor is going to connect to the bottom leg of the photodetector, so I'm going to go from column 15 to column 20. So you see there's a connection between those two. Now remember, this whole thing is going to connect to, I will use the red wire, the whole thing is going to connect to, all right, let's look here. I've got the left leg of the photodetector is going to go to 5 volts. It will go to 5 volts like that. Now the bottom leg of the resistor, remember, that is going to go to ground. I'm going to use a black wire for that. So that is going to go to GND. Now it is this center. It is this center. What is that? Sorry. Let me clear this up over here. Okay. It is this center connection between the photoresistor and the normal resistor, the fixed resistor that we want to measure. And so I will grab a wire into that column, and then I'm going to bring that over to A0. All right, so now this is all hooked up. And so what we need to do now is we need to read the value off of A0. And what we should see is we should see that that changes as the light changes. So we should read a number. It's not going to be, it'll be between 0 and 1023, but it won't go over that full range. But it should be numbers between 0 and 1023. And then we need to record the values that are indicated when the light is off, and then record the values that are indicated when the light is on. So I need to come over here and open up a fresh IDE. Okay. Let me get this, and I know I need to switch over where you guys can see it. All right, so let me get this over here and see if I can get a good view here. Perhaps this will be, that is a pretty good view, don't you think? You can see everything that is going on. And so let's come up here. And this is going to be pretty easy code because we've got a fixed 5 volts across the photoresistor and other resistor. We don't have anything to do there. We just have a pin which is going to be A0. So we are going to call that light pin because we're reading the light there. And that is going to be equal to A0, I believe. And then we're going to need int, we're going to need light val. That is what we're going to read off of that pin, and so we don't need to put a value in there. We will need to do a pin mode. So we're going to do pin mode. We are going to do light pin is a what? It's an input. We're reading from it. Input like that. All right. Now down in the void loop, what do we want to do? It is pretty simple. It is going to be pretty simple what we are going to do is we are going to read from that pin. So what do we do? Light val is going to be equal to analog read of what? Of light pin. And so we're just going to analog read. And then let's turn on our serial monitor up here because we want to print. So we do a serial dot begin, and we'll do the trusty 9600. Oops, I hit some strange key there. Okay, 9600, like that. Okay, I'm hitting the wrong keys, 9600. So now, light val we've read, so we're going to print it now. Serial dot print ln. And what are we going to print? We are going to print light val, because we are reading that. And then I'm going to put a delay of, I'll put delay value, and then I will come up here and be a good person and use variables. Int delay value is equal to 250 milliseconds. All right, so this should just sit, and it should read, and it should print, and I'm going to try to move to a view where hopefully you can see this, but let's go ahead and download this. Hold your breath. Oh, it's gonna work. Okay, so now let's turn on the serial monitor, and let me see if I can get a window where you can see the serial monitor. Look at that. All right, so we are reading a number between 0 and 1023. Now let's remember what we think is going to happen as we change the light. Okay, as I turn the light off, the resistance is going to be higher. As the resistance gets higher, the current gets lower, and as the current gets lower, the voltage is going to drop. Okay, the voltage is going to drop. So as I go in, let me say that again. As I turn the light off, the resistance of the photodetector will go up. As the resistance of the photodetector goes up, the current will go down. When the current goes down, then the voltage across that 5K resistor will go down. So the voltage of that across that 5K resistor will go down. So what do we expect to happen when I turn the lights off to this number? We expect it to go down by probably a factor of 2. Boom, it went down even more than that. Do you see that? It went down to 200, about 200. Now it's up to 700. Why does it go up? The lights are coming in. It's generating electron hole pairs in this photodetector. The electron hole pairs make it more conductive. When it becomes more conductive, the resistance goes down. When the resistance goes down, I get more current. More current leads to more voltage across that. Boom. Okay. Now, what your assignment is to hook up a circuit which will turn if the lights are on in the room, you want the green LED. Everything is okay. Green, the lights are on. But if the lights go out, you want to turn on the red LED. Okay, you want to turn on the red LED. Now, to make this work, you're going to have to look at what these values are. Like what we saw in this room, that when the lights were on, it was around 200. Okay, it was around 200. And when the lights, when the lights were off, it was around 200. And when the lights were on, it was around 700. Okay, so what I want you to do is I want you to set up a circuit, and I want the red LED to come on if the lights turn off in the room, and I want the green LED to turn on when the lights are on. You go do that by yourself, you figure it out, and then when you come back, I'll do it with you. But do it yourself, get it working, and then when you come back, see if you did it the same way I did it. Okay, let's see what I am going to do. I'm going to first switch over here to this view so you can see me hook this up. You ought to really be adept at this point at hooking up LEDs, so I'm going to go pretty quickly. I'm going to put my red LED in column 25, I guess I'm going to start with my current limiting resistor. Current limiting resistor is going to go from column 25 to column 30. All right, and then the long leg of the LED needs to point back towards the voltage source, so I'm going to put it in column 30, and then the short leg of the LED is just going to be over a couple of columns. Now to hook that up, what I am going to do is I'm going to bring column 25 to pin 9. Okay, so one of the pins that I will be using to make this thing work will be pin 9. Now I'm going to repeat that for the green LED, but I'm going to go from column 35 to column 40, from column 35 to column 40. Then long leg of the LED connects to the resistor, short leg a couple of columns over. Then I'm going to connect that to that resistor to power it over to pin 8. Okay, it's connected to pin 8. And now I need a couple of ground wires, right? I need a couple of ground wires. So the lower leg, the short leg of the green LED is going to go to, and I am running out of ground wires, but I think I can still do it. I'm going to go to the ground that's over there beside pin 13. Okay, the ground beside pin 13 for the green LED, the ground beside pin 13. And now I still need to ground the short leg. I need to ground the short leg of the resistor. I mean the short leg of the LED. Guys, if you are not following this, go back and look at, I think, lesson number 3, where we showed you how a breadboard is, but how a breadboard works. But I'm getting to the point, I mean, I've got to do this stuff faster. I can't every time go real slow to show you how to hook up an LED. You should know how to hook up an LED by now. And so there is another ground pin here by 5 volts, which I'm going to connect to. So I've got the 5 volt going to the top of the photodetector. I have a ground coming from the resistor that's in series with the photodetector. Then I'm supplying power to the current limiting resistor of the red LED by pin 9 and the green LED by pin 8. So if you guys have been following along, you ought to be able to do this with me as I do it quickly. And if you haven't, you just need to go back and look at some of those earlier lessons. All right, let's get some coding done here. And let's see, what was that most excellent view where you could see me and the serial monitor and everything? I think this was it. Let's see if I can make this any. Okay, so now we are going to come up, and we can probably use a couple of these values. We still have light pin, we still have light val, we still have this, so those are pretty good. I need int, I need red pin, and the red pin was pin 9, equal 9. All right, and then I need int, and I need green pin, and that was pin 8. So that's going to be equal to 8. And now I need to do a couple of more pin modes here. I need to do pin mode, and I need to do red pin is going to be an output. And then I need to do a pin mode green pin, and it needs to be an output. All right. So my pins are set up. Now I'm still reading light values, so that's good. Now what did we say? We said the trick is to kind of figure out where you are going to set your values. And it seemed like when the lights were out, we were at about 200, okay? And then when the lights are on, we were at about 700, all right? let's see, yeah. You see this little wire had gone over the photosensor and it kind of cast a shadow on it and the value went down. Okay, so what we need to do is we need to do some if statements. And this is what I want you to think. Don't say if it's equal to 700 or if it's equal to 200, because it's kind of, there's variations and there's in between values. So how do you want to do it? Well, if you have like lights on at 700 and then lights off are about 200, how would you want to do this? Well, what I think I would do is I would say if, and then what am I looking at? Light val. Okay, if light val is greater than 350, what do I know? I know, and then I'm going to open my clause, and then Arduino adds the close. What do I know in that case? Well, in that case, I know the lights are on. If the lights are on, everything is good. So I should do a digital write, and then I should do green pin should be what? High. All right. Now, what you would probably think is, okay, now I'm going to go do if light val is less than 350, then I'm going to say red pin is high. That's right, but you got to remember, you've got to undo what you did. And so if you come in here, you've got to also remember, what's the other thing you want to do? You want to turn the red pin, what, off. Because if you didn't do that, then they're both going to stay on. So you got to remember to kind of clean up. All right, now what's the other one? If light val is what? Less than 350. If light val is less than 350, open the clause. Now what do we want to do? We want to do the opposite. So I'm going to just copy these, Control C. That was... I hope I have an undo. I don't know what I did there. Okay, let me get those in Control C and then come down here, Control V. Now this time we want green pin to be what? Low, and we want red pin to be high. So what we want this to do is we want this to warn us if the lights have gone off. let me download this and see. Okay. Lights are on. We're good to go, right? Lights are on. We are good to go. And in fact, let me just leave it like that, and I will come over here and I am going to turn off the lights. And nothing happened. We have an error. Houston, we have a problem. So let's see. 200, the values that we're reading, 200 is less than 350. So if I say if light pal take red pin high, I might have a problem how I hook this up. So let's see. That's grounded. The orange comes to pin 9. Let me make sure I did pin 9. Can you guys see what I did wrong? Red pin is pin 9. Comes over to my resistor. Long leg of the resistor is there. I do come back to ground. Okay, so guys, a lot of times I make mistakes on purpose, but I did not make a mistake on purpose here. And so I want you to see that this is not working. And so what I want to see is my basic LED circuit working. So I've got the current limiting resistor on the red LED hooked to the red LED. I'm going to take this wire that is on that circuit, and instead of pin 9, I'm going to hook it to 5 volts. And when I do that, it comes on. That tells me the circuit is working. So now I need to come back to pin 9 and put it in, and I need to figure out why it is not working. There it is. Okay, so probably what had happened, why was that not working? Man, this is great when things go wrong like that. Probably I just had a loose connection and it wasn't working because of that. All right, so let's play around with this. Let's play around with this. Lights are on. I actually think you can see this better when we were in this view down here like this. I actually think the LED shows up better. Maybe not. Let's try this one. Okay. You can clearly see that the green light is on. All right. Now we're going to turn the lights off and the red light comes on. Green, red. Okay, guys, let's review what is happening. Let's review what is happening. When you have light, you generate electron hole pairs. It becomes more conductive, which means the resistance drops. When the resistance drops, you get more current, which leads to a larger voltage across that series resistor. When you turn the lights off, the resistance goes up. When the resistance goes up, you have less current. When you have less current, you have less voltage across that resistor, that fixed resistor that you are hooked up to. Okay, guys, we went all the way from solid state physics to hooking up a circuit based on a little circuit design based on, and then hooked up the Arduino and coded and make things work. And this is how you work if you're a real engineer. Man, this is how you work if you're a real engineer. You got to start with physics. You got to do a little math. You got to do a little circuits. You got to do a little engineering. You got to do a little coding, and then you hook things up and you make it work. I feel like I'm getting a lot of hate on these where I actually go in to try to help you understand how things work. But at the end of the day, someone has to know how these things work, right? You can't just sit and copy and paste people's code the rest of your life. You need to learn a little bit of the physics. You need to learn a little bit of the math. All right, this is Paul McWhorter from TopTechBoy.com. Hopefully you guys will give me a thumbs up. Hopefully you'll subscribe and share this, and I will talk to you guys later.